This research paper, titled Advancing Arabic Speech Recognition Through Large-Scale Weakly Supervised Learning, is authored by Mahmoud Salhab, Marwan Eljatani, Shamed Sait, Syed Sibgat Ullah, Muhammad Abashik, and Hassan Abashik from the CNTXTAI department in Abu Dhabi, UAE. The paper focuses on improving automatic speech recognition, or ASR, for the Arabic language using a technique called weakly supervised learning. Automatic speech recognition is the technology that converts spoken words into written text, making it essential for human-machine interactions. It's used in various applications, such as conversational agents, industrial robotics, call center automation, and even automated subtitling. However, building high-performance ASR systems is particularly challenging for languages like Arabic, which are considered low-resource. This means there's a lack of large, labeled datasets, and creating them requires expensive and time-consuming manual work. In this study, the researchers address this issue by training an ASR model using weakly supervised learning. They employ the Conformer architecture, which combines the strengths of convolutional neural networks and transformers to process speech data more effectively. The model is trained from scratch on a massive dataset of 15,000 hours of speech data. This data includes both Modern Standard Arabic, or MSA, which is the formal version used in media and education, and Dialectal Arabic, or DA, which varies by region and is more commonly spoken in everyday conversations. What's innovative here is that the data is only weakly annotated, meaning it doesn't require precise, human-verified transcriptions. Instead, the annotations are approximate, which makes the process much more scalable and cost-efficient. Despite this, the researchers achieved state-of-the-art results, outperforming both open-source and closed-source models on standard benchmarks for Arabic ASR. This demonstrates that weakly supervised learning can be a powerful alternative for developing ASR systems in languages where high-quality data is scarce. To understand the context, let's delve into why Arabic ASR is so important. Arabic is the fourth most used language on the Internet and one of the 6 official languages of the United Nations. It's spoken by millions across 22 countries, making robust ASR systems crucial for applications in healthcare, telecommunications, smart homes, and more. Arabic has 3 main forms: Classical Arabic, which is the ancient language found in religious texts like the Quran; Modern Standard Arabic, a standardized version used in formal settings; and Dialectal Arabic, which includes various regional dialects that differ significantly from the standard forms. These variations add complexity to ASR development because models need to handle diverse accents, vocabularies, and pronunciations. The challenge with Arabic, as a low-resource language, is the limited availability of transcribed speech datasets. While efforts like the MASC and SOTA datasets have helped, they are still small and not diverse enough to train models that generalize well. Traditional neural network-based ASR systems require vast amounts of accurately labeled data to perform well, but gathering this data is labor-intensive and costly. In response, the paper proposes using weakly supervised learning to bypass these limitations. By training on 15,000 hours of weakly annotated data, the researchers eliminate the need for manual transcriptions, which can be both time-consuming and expensive. The Conformer architecture plays a key role here. It integrates local and global feature extraction, allowing the model to capture both fine-grained details and broader context in speech signals, which is particularly useful for the nuances in Arabic. The results are impressive. Even without human-verified labels, the model surpasses previous benchmarks, showing that weak supervision can lead to high-performance outcomes. This approach paves the way for more accessible ASR development in other low-resource languages, potentially revolutionizing how we build speech technologies worldwide. Now, let's look at the broader implications. The paper highlights how ASR enables seamless human-machine interaction, allowing users to give verbal commands in real time for tasks in areas like law enforcement, criminal justice, and consumer electronics. For Arabic speakers, this means better access to technology that understands their language naturally, reducing barriers in global communication. In the literature review section, the paper covers existing research on ASR, weakly supervised learning, and specific studies on Arabic ASR. It notes that while neural networks have advanced the field, the data bottleneck remains a major issue. Weakly supervised methods, which use less precise labels, have gained traction as a way to scale up training without the high costs. Moving to the methodology, the researchers outline their approach in detail. They start by preparing the weekly annotated dataset, which covers a wide range of Arabic speech variations. The Conformer model is trained using techniques that leverage this data effectively, focusing on minimizing errors despite the weak labels. The paper emphasizes that this method not only achieves SOTA performance but also offers a blueprint for future work in low-resource settings. Overall, this research underscores the potential of weekly supervised learning to democratize ASR technology. By making it easier and cheaper to train models for underrepresented languages, it opens doors for more inclusive AI applications. The paper is organized with a comprehensive literature review in Section 2 and a detailed methodology in Section 3, followed by likely sections on experiments, results, and conclusions, though the provided content cuts off there. This work is a significant step forward, showing that with innovative techniques like the Conformer architecture and weak supervision, we can overcome the challenges of low-resource languages and build more effective speech recognition systems.